Okay, so welcome again to the DIREC Talk on Graph Models for Knowledge, Regulations, Rules, and Processes. My name is Professor Thomas Hildebrandt, and I will give the talk jointly with Associate Professor Tijs Slaats and Assistant Professor Hugo Lopez, who will show some of their part of the research on models for regulations, rules, and processes. And yeah, a bit about myself, just one slide. I'm head of the research section for software, data, people, and society at the Department of Computer Science. And I'm leading several research projects on effective and accountable digitalization. I'm also a member of the Danish Standards Group on AI and sit in on the cybersecurity group. So I'm following the work on standardization and contribute as good as I can. I also took part in the advisory board for the new DCL, the marking we have now in Denmark for responsible use of data and data security. And then I'm head of the PC workstream in the DIREC Research Center, of which this talk is part of the DIREC series, where you will see more PhD courses coming up. Privately, I'm also a consultant and lecturer on digitalization and AI. And before coming to University of Copenhagen, I was 18 years at the IT University of Copenhagen, just after completing my PhD in computer science. Below, you see some of the research projects I've been involved in. The DiKU project was funded by the Innovation Foundation, and it has just ended last year. And many of the results we will see today is from the DiKU project and building up to the DiKU project. Right now, I have then 3 projects ongoing jointly with the 2 of them jointly with the Faculty of Law. One where we look at the transparency of algorithms from a computer science and a legal perspective, and one where we look at data science applied to migration decisions and processes. And finally, I have a project from the Independent Research Fund Denmark on a new foundation for programming languages where you can trace data and take into account accountability and robustness of context-aware distributed systems. In DIREC, we have just started 2 new bridge projects. One is business transformation and organizational AI-based decision-making, led by Arisa Shollo at CBS, where I'm to be co-supervisor, which is continuing the agenda of the work I'm presenting here in this talk. And another project that is headed by Tijs Slaats, that you will meet shortly, is on also related to this project, but also combining blockchains for again for this accountability in complex business processes. But there will be a strong element of process mining that Tijs will tell you about in the talk. So Tijs, should I try to give the word to you?
Yeah, thank you. So hi everyone, I'm Tijs. I'm an associate professor at the University of Copenhagen, a part of Thomas's group. So my research interests are in process modeling. So I worked a lot on this declarative process notation called DCR graphs. I have looked at kind of more understandability studies, understanding how we can kind of fine-tune these notations to be more accessible for business users. So my work also lies very much in kind of the field of formal methods. So I it's the notation is formal, and we do a lot of interesting kind of formal things with this as well. And then at the moment, also kind of some key interest for me is process mining. I'll talk a little bit more about that, but essentially you can look at it as kind of the intersection between machine learning and kind of this work on business process modeling. So we try to use machine learning techniques to create models from historical data. And then I also do bits, both in my PhD, I worked kind of more with the distributed systems view. So I looked in particular at kind of using these kind of declarative notations for cross-organizational processes. So I also have a strong interest in distributed systems and these days in blockchain, because everyone is hyped up about it, right? And at KU, my position is also officially in software engineering, and so I also teach software engineering courses there in architecture, which comes a little bit less in play in my research. Yeah, and just I have some various research projects that I work on. So the main ones at the moment is two projects that we're Thomas is also involved in, where we're working with Faculty of Law, where we kind of investigating why there are big discrepancies in the exception or rejection of asylum cases between different European countries. And already actually in the Nordics, you can really see a big difference, for example, between Sweden and Denmark. So people that come from Afghanistan might have a pretty good chance of getting accepted in Sweden and a very low chance of getting accepted in Denmark. And well, in principle, this shouldn't be the case. So we're trying to come with some machine learning tools to kind of look at all the data we have available and try and figure out if we can see why this is happening. Then within DIREC, I'm leading this AI and blockchains for complex business processes project. I'll talk a little bit about it more on data. And then also we have this public project where we're doing a bit more also blockchain oriented work. At least that's my role in there. Yeah, so I think we can pass on the token to Hugo, if you can hear us, Thomas.
I can hear you now. Thank you. It was we discovered it early in the talk. So Hugo, maybe you can say a few words about yourself.
Can you hear me now? Yes. The most used word. Hi, everybody. My name is Hugo Lopez, and I've been in between research and industry for the last 14 years. I did a PhD in formal methods for distributed systems, session types, and other ways of coordinating different services. And in the last few years, I've been concentrating my work in business process management. How do we model? How do we verify from a formal perspective? How do we do verification with respect to legal requirements and natural language requirements? So there's also kind of a lot of the questions on how do we formalize law? How do we extract formal models from like natural language specifications? And there's also a lot of these questions regarding how do we apply machine learning and specific natural language processing to formal verification. So how do we integrate AI into FM, so to say? And in this lecture, we're going to talk a little bit about the extensions on DCR graphs, on how do we use them in order to achieve some of the kind of sustainability goals.
Just briefly, Hugo, me, and Tijs are part of the STPS research section for software, data, people, and society, and it spans the spectrum from software engineering and formal methods, blockchain, process modeling that we have represented in the speakers here. But then we also have a strong data management systems group, a group looking at critical data studies of the use of data for AI in particular. Participatory design, computer-supported cooperative work, looking at the interplay between humans and computers in work practices, health informatics, and trustworthy AI. So we are contributing, building bridge from the technology to people. And that comes to these sustainability goals and sustainable development. So if you look at it, to have a sustainable development is really depending on making the right decisions in our business, in our public sector, in our private life. And what is necessary to make these decisions? Well, we need representations of rules, our knowledge, processes, data, regulations, either in our heads or in our computers or in a mix between computers and our heads. And that will support us making better decisions of how to govern businesses, private life, but also how to live our lives. And to build these models, that's not just something we do once and for all. I mean, that's an iterative process. So we have an iteration down at the bottom here where we use models to make decisions, and that again feed back into our system describing a new state of the model. But before doing that, we also have a stage of model selection in the middle where we select, okay, what is the model we're going to use right now to understand and to manage our process. And finally, we have a loop on model creation. And all these loops interact because we learn new things. We find out when the model is no longer representing the reality good enough, or if we have removed something in the abstraction when we made the model that we need to put in again. So a lot of the work we're talking about today is how to build a traceable map between real-world concepts and including regulation and models that we can use for supporting our reasoning and our workflows and business processes. And today we have many regulations and many different interpretations of regulations. So the supervisory authorities, they have one representation, citizens have another representation or interpretation, and our public organizations and businesses, they also implement and interpret regulations in some way. And all these interpretations are more or less different. Of course, we agree on part of it, but there's a lot due to the informal nature of text and the complexity that will be different between these stakeholders. And at the same time, we are trying to put in computers. And computers, they are kind of very rigid. So they will also have an interpretation given by the code we are giving them. And we try to make people and computers work together and to give this semi-automated or fully automated business processes and workflows and decisions in our society. So we have this concerned person in the bottom here saying, well, we know that everything we are making, basing our decisions on are really models, and they are not going to be perfect. That they will differ from reality. We also have a trend in Denmark, but also in the European Union, in the Commission, and also in New Zealand, on making laws and regulations machine-readable and ready for digitalization. And there's some interesting reports here from New Zealand, and also an interesting community you can join in the European Commission, following these kind of trends and works and tools. And the warning here is that a risk also mentioned in this report from New Zealand is that when we code laws and regulations, we have also interpreted it in a way that is difficult to challenge by people not understanding the code. So that's also kind of part of the background of the work we are representing here, that in order to have code representing regulation, we also need to have it in a format that domain experts, lawyers, citizens can challenge and say this is a wrong interpretation, or this should be interpreted in a different way. Because if you get a fixed representation or interpretation of the law in code that we cannot challenge, then we have effectively excluded the courts and the judges from the loop, and they can no longer have the final say on what is the right interpretation. And also we need interpretations to be able to change over time. So we also need a very flexible, adaptable system. This is not a new idea. It's an old dream of automating and supporting workflows and business processes. And the notation has not changed a lot when we try to describe processes. So in the 70s, they were drawn by hand. Now we have computer tools, and we have standards for how to draw these workflow diagrams and business process diagrams. We also, however, have notations for formulating these decision rule tables as DMN, And we have new technologies supporting the when to make a decision, like artificial intelligence. And there we can have a clear challenge comparing these kind of decision rules that are interpretable as if-then-else rules, and then a neural network, which is really just a memory remembering some previous answers to the decision and trying to generalize and say this case we have right now looks mostly like a yes case or a no case. So does it work in practice? Well, many systems where we have simple rules and simple processes, it works. But unfortunately, we also have the tendency with the kind of old technology, at least the one before the one we have introduced the last 10 years here, that the processes become too rigid. So we have situations where we need to work outside the system. And then we kind of lose all the benefits of having computers assisting us because we don't get documented the steps of the process, and we don't get any decision support. We also have examples where people are implementing systems without really knowing their workflows, and then they get the wrong workflows inside the systems. Or it could be we get the wrong legal rules in the system. So we have a system collecting illegal taxes. And we have the healthcare platform with wrong codes for sending out doses of medicine or deciding when someone should have a heart operation. And finally, we have a lot of places where compliance is mostly digitalized in the way that the documents have become digital, but it's still only documents. So for instance, in the financial sector, we use more than 3 billion kroner a year in Denmark to try to keep up with the legal compliance requirements. And still, there are many administrative orders given in the financial sector. But we clearly have a challenge, and as Hugo also will talk about later, I mean, now we also then have new regulations from on the sustainability, the green taxation, and there are also new regulations, CAP 2020, for how to give support to farmers and so on. And we are overwhelmed by new regulations trying to help us getting a more sustainable society, but our businesses and public sector cannot keep up with the load. So what should we learn from these 40 years of process digitalization? Well, we should learn that processes are not just highways where we can force people to really drive only on the highway. People also need to have flexibility in most of the cases, actually. So we should move our focus from automating the highways to support navigation in the complex and changing rules and regulations. It's more like driving in a city where we can change our goals, and we can also change the map of the city when we have a blocked road. And then we should also support getting new knowledge where we do not have any roads, where we do not know exactly the rules, so we can mind what are the rules that people are following here and learn from that. So the metaphor behind the work we have been doing is that we need a representation of the rules that can be understood and maintained by the users, so we can use the computers to dynamically help us compute and validate the suggested routes, instead of trying to just map out the routes and then hope that people need to drive where we put the routes, which is would easily lead to these empty highways that we see somewhere in Jutland. So that was kind of the background for the ECONO project that started in 2017, and ECONO was short for Effective, Co-Created and Compliant Adaptive Case Management for Knowledge Workers. And we also had analysis from the Ankestyrelsen, where they investigated practice, and several of them shows that there were many compliance violations and violations of the law. In cases that could have really serious consequences for citizens if they're applying for support, if they have chronically ill child or a child with a handicap, then you cannot wait 2 years to win a case after a complaint. You really need the money when you apply for the money. So the vision was to create value for the society and partners by develop these solutions for effective digitalization of knowledge work processes, not to tell exactly people what to do, but to help them say what are you kind of obliged to do, what can you do, what are the rules that you have to follow. And then to empower caseworkers and citizens to make the decisions and plans according to that, also using data of past cases. And that's not, I mean, it hasn't changed the situation on the legal complexity. So recently we had this report coming out from Justitia showing that the complexity on the social service area is still very, very complex. So it's still very much needed. So that's the challenges in the municipalities, but also many other places that we have complex, frequently changed regulations. We have an increasing caseload. Our IT system do actually mostly they do not know anything about the processes they're part of. Maybe they know the name of the area and the name of the law, but they don't know anything about what to do according to the law, most of them. So the process disappears when the system is implemented, which is probably good as long as people only use these flowchart notations or code. But if they could use a more flexible, traceable model of the law, we could actually get much more support for our caseworkers and our businesses. Yeah, so here's the example of the praxis investigation showing that there were more than half of the cases were not legally correct. So we divided the project in 4 work packages. One was focusing on the computer-supported cooperative work and based on ethnographic studies of caseworkers, mostly in Syddjurs Kommune municipality, but also in Gladsaxe. And then we had something we will hear much more about in this talk, a work package where we look at mapping from text to formal rules, so we could support the caseworkers following the law. Then we had a PhD student looking at the understandability, doing eye tracking experiments with different kinds of users, see how do they use the notation, the text, and the diagrams, and so we could continuously improve them. And finally, we have a PhD student at KMD looking at how can we then, in a responsible way and in an explainable way, use data to help finding problems in cases or finding bottlenecks or unwanted waiting time. So the key enabling technology is this dynamic condition response graph that has been developed in more than 10 years of research, jointly between my research groups and now also spreading out in the world in other research groups and then industry, where we have the company DCR Solutions that was founded as part of Econo. It's a declarative graph-based model, meaning that we capture why and not just this blue route, saying follow the route. We actually capture the roadmap of what are the possibles, what are the obligations. And it can be modeled incrementally. We don't need to have an end-to-end model because we don't model the start and the end. You can add activities that you want to represent in your systems and gradually add rules and remove rules that are no longer correct. And that way you get a much more maintainable model that can also be mapped to the rules in the law. And then because it has a formal semantics, it actually understands, supports validation of the rules. You can do simulations before you put it out in the case management system, and formal analysis, so you can see if there could be problems in the process. And it's documented in more than 40 conference and journal papers that you can also see on these websites from DCR Solutions and DCRresearch.org. So the overall idea is that we can now highlight and mark up law text that become formal graph models that can then be directly executable as decision support and workflow support in IT systems. So they are traceable from the law text to the implementation. And it's part of this bigger compliance framework where we have compliance officers and legal experts interpreting the regulatory documents, creating reference models, and then we can do use them for compliance check against the actual sequences of cases, or we can put them into the case management system so we can get compliance by design. And then we can do these iterations and loops, and feeding back the event logs, do process mining, and find out what are the real models or the rules people follow, and in that way learn from the past. So here's the overview of the approach. We have the mapping between text to formal rules that gives this formal representation in the design tools, where we can do simulations to validate. Then we can use them either as just dynamic guidelines, where you can look up what are the normal flows that could be the highways or some exceptions that are worth showing people, or you can use them as executable decision support to say, okay, what should I do when I start a new project and I need to comply with GDPR, for instance. You can also get it into your case management system. And here we have an open source client that is being used in studios and the SPSys grouping of municipalities. And it's also embedded in the KMD work zone system used in many central government institutions in Denmark, and also now exported to Australia and New Zealand. And so it's because KMD has been bought by NEC, so it's now a part of a global company. Finally, you can do this analysis loop where you show, okay, what are all the paths people follow? So Inforentia have made a tool for that, but DCR Solutions also implemented the process mining algorithm Tijs will tell you about briefly. So you can actually learn what are the rules that characterize the unwanted behavior, what are the rules that characterize the wanted behavior, and then you can see the difference in behaviors like that and learn from that. So, and finally, we contributed to the standardization work in the AI group in Danish standards, where we made this specification on how to include stakeholders already from the idea into the design of AI-based decision support. So you can find this free specification on the Dansk Standard webpage. So here, if you zoom in, here's an example of two small subsections of paragraph 155 in the service law, and you can see how within 6 business days has been marked up as a rule, and it connects receiving a notification from a citizen to acknowledging the receipt, and that becomes a blue rule that you have to acknowledge the receipt within 6 days after receiving a notification. And similarly, we have the other activities: inform the notifier, special circumstances exist, they become activities in the formal model. And as Hugo will explain also briefly, this can be done manually, but we're also working on tools where we can get a first markup by NLP technologies, so we don't need to do everything from scratch, but we can get help here also from technology. But of course, that will never be perfect. As we know, so we need a human in the loop to actually complete the interpretation of the model. The 5 core rules are the conditions, saying something must happen before something else. Responses, saying that if something happens, something must happen eventually or within a deadline. Exclusion, saying that if something happened here, this is we make the decision that there are special circumstances. Then we remove this activity from the model, then we should not inform the notifier. Inclusion, that's the opposite. If we decide there are no special circumstances, we can include this activity of informing and notify again. And finally, the milestone is saying that if we are still have an obligation of doing this, finding out if there are special circumstances, we should not go ahead and inform the notifier. So we can block an activity if another one is required pending activity. Then there are many extensions of the models that have been gradually developed, and they are conservative extensions. So you don't need to understand all the model notation before you can start using this already. So the time is one extension where you have the deadlines, but you can also make delays on conditions saying that you have to wait, for instance, 2 days after receiving notification to start a new investigation. Then you can put a 2-day delay on this relation. Then we have data and time. So instead of just ticking that now we did something, we can also provide data as part of this event. And that data, in this case, either 0 or 1, can influence the constraints and the models. So we can, and we can also do computations now as part of the model. So we can actually implement a full end-to-end web form combined with a workflow that get data in, process, and make decisions to include some tasks and exclude other tasks, or make some tasks pending and required depending on the data. Then we have extensions of subprocesses and network of linked graphs that I will briefly show in a moment, because processes are cannot just be modeled as one big graph. But also we know regulations, they have references to each other. So therefore we need a way to say, well, this activity is actually referred to also from other paragraphs. So we need these networks of linked graphs. And another way of doing abstraction is to say this activity, initiate an investigation. Well, that could actually be a sub-process where you model all the parts of an investigation to describe that. That could be an example of a sub-process. So we can validate by simulation, and here's an example from the tool. I think I will dare going online. Let me see if I can exit the full screen. It's not, maybe here. No, I have to stop my screen sharing perhaps. It's a bit annoying. Well, anyway, what I would like to show you in the tool is that you can, at any point when you do these models, press simulation, then you get a checklist where you see what are the possible activities you execute. And here it's only receive notification. And once you execute it by clicking it, then you get the next checklist dynamically computed. What are now the available activities? And here you see you have to acknowledge receipt within a deadline. You can also see what is the path you have followed so far. If you click on this special circumstances, then it opens a web form, because this was a data event. It's a very simple one. A more complex one would include many activities like a sub-process, but you can model all that in the same notation. And we get this data input, and it influences these rules if this determining whether this activity should be included or excluded. And in this case, I said, well, there are actually special circumstances, so therefore this should be excluded. So now you can see it's dashed, so it's no longer part of the model. This linking between the models, you can see here in the same law, paragraph 48. It states before the municipal council makes a decision under sections, and there are many sections. So there are decisions in all these sections. The child or young person must be consulted on these matters. So there's a law here, a rule in one paragraph that refers to many other paragraphs. And that we can model by having renamings and links between different graphs of different paragraphs. And in that way, we can combine different paragraphs. And in fact, this rule was one of the rules violated often in this practice investigation, because people don't see that there's a condition stated in a completely different part of the law than the law they're focusing on right now, or the paragraph they're focusing on. So the next thing in this tool chain here is then when we have executed processes, they make event logs, and from these event logs we can learn. And Tijs, you can take over here.
Yes, thank you. I'll try and ask for control so I can let's see if that works. There we go. Then I can click myself. Maybe it's a little bit much to ask for, but okay, let's see if it works. Thank you. Yeah, so it's fine now, it's almost. Otherwise, I'll just ask you to click.
Okay.
Yeah, good. Okay, so like I said earlier, right? So process mining is essentially a combination between machine learning and kind of process modeling. So the idea is that you have these kind of event logs, like you can see on the left here, where you have somehow recorded data on how your company has been doing work in the past. So typically these event logs consist of some kind of case ID, so the specific process instances that you're interested in. So here you have one here that it's with 0 here, and then you have another one that's with 2 here, and another one starting here. Then you have events in your event log, of course. So each event is precisely the execution of an activity at a particular timestamp. So here we can see that in this case, we started out by filling out an application, then the application was approved, then we changed the phase to review, and so on. We can also have roles, of course, and we can have all kinds of other data attached to these events. But the key things here are really that we can somehow identify instances. We have activities that happen at a certain point in time, and that's the kind of the core data we need to be able to do process mining. What we can do with it is that, for example, we can then start looking at these instances, find possible bottlenecks in the process, locations where we can see that the process often kind of stalls, where there's often delays. We can identify particularly troublesome cases and start looking at how these are different from the cases that work fine, that end in either because they end more quickly, or maybe the outcome of these cases is just not desired. And by comparing these to the normal cases, we can then start seeing what is now the difference in kind of the way we do our work that might be causing these cases to end in undesirable ways. We can check if real processes conform to our model. So if we have a model, we can kind of hold it against an event log like this and check if it follows the model as we expect it to, or if people are doing things differently in practice than what we expect. And a big field is also something what we call process discovery, so where we actually create models based on these event logs. So we're essentially taking real world behavior, and now instead of saying let's model things up front based on interviews with users and so on, we just say let's look at the data and let's see how do people do their work, and can we now automatically generate a model of how people do things. Okay, click. Yeah, thank you. And a key point here that I would like to make, right, is that essentially doing process discovery is very much a way of doing explainable AI, because these models we get out, right? So we come with some data. It's a description of behavior of people, and the model we get out that then can kind of predict this behavior afterwards. It's at the core, it's meant to be human readable, right? It's meant to be understood not just by experts, but even by regular business users. So all the time we've been working in this field of process mining. There's always been kind of this approach of doing explainable AI before this field really became the big topic that it is today, right? So I think there's a lot to learn here from how things have been approaching process mining, because we've been trying to solve this problem for a long time now. Of course, it's a limited problem, so I'm not claiming that this will solve all machine learning problems and make all machine learning problems explainable. But for the problem that we're trying to solve, we've kind of solved it already. Yeah, thank you. What we have worked on at DIKU is one of these kind of discovery algorithms. We call it Discover because it generates DCR graphs. And what we have shown is actually that this is both. We can show theoretically that this miner has linear runtime complexity. That's the case for many of these miners. But when we actually do practical experiments, we can also see that it's actually orders of magnitude faster than competing algorithms. So this is one of the fastest, or maybe the fastest, discovery algorithm that is out there today. And this year we also won a contest called the Process Discovery Contest, where people kind of get to submit all their algorithms, and then they are compared to each other based on their accuracy. So what they do is that they have a large set of synthetic training logs. Then there is some complete label test logs that show the model you put out when you train on this log should accept these traces and reject these traces. So we won this contest. We had we gave the most accurate models with our miner. Like you can see here on the right. So if you look at the average scores, Discover is there in the middle. They're significantly higher than kind of what the state of the art is, right? The only competing miner is this log skeleton miner, which is very close to us. But every other miner, they really perform much worse than us. So this was a really nice result for us. We really showed that we could do things much better than they have been done until today. A nice interesting point was that one of the reasons kind of the contest organizers thought that we were doing better was because we used this declarative approach. And they had noticed, because this log skeleton miner is also a declarative miner, that these declarative miners just do better than imperative miners. So what they did was that they gave a consolation prize for the best imperative miner, kind of to encourage submissions and also give them a chance to perform well, right? But of course, we like winning. So what we did was that we actually showed that we can map our declarative models quite easily to an almost exactly the same imperative model. So that's why we managed to actually win both prizes. We also managed to win the consolation prize for the best imperative algorithm, which was a bit funny. Yeah, next slide. So that was just shortly what I work on, right? Okay, one of the main things I work on. But of course, there's still a lot to do here. So currently we have some work going on to process discovery with labeled event logs. So these days it's actually quite uncommon in the field yet that you consider that your input might be classified in a way that you might have both examples of bad behavior of people and examples of good behavior of people. So we're kind of looking at if we know that beforehand, right? That certain executions of processes in the past went bad, had an undesired result. Can we then use that information to generate better models? We're actually getting quite far with it now, and we're also showing that doing this actually helps improve the quality of the models. Then, as Thomas talked about, right, there's all kinds of other perspectives on these models. So it's not just control flow, but we also have time, and we have kind of contextual data that we might be interested in modeling about, because if we have a reimbursement process, right, the amount that people are asking for to get reimbursed might influence the flow of the model. So kind of getting these perspectives into the mining task is also something we're working on. Incorporating more domain knowledge. So if we actually know that there are laws and regulations that constrain the way our process can behave, then we could take this in, right, and use this in the learning task to get a more correct model. So that's something we're looking at. And also improving kind of model understandability through user feedback. So kind of going back to this idea of making sure that the models we output are kind of the ones that users can really use and that are helpful for them. Yeah, so that was in short.
I will move on then. Thanks a lot. So so as Tijs said, these understandability studies were already started in the Econo project. So this is what Tijs is continuing, including these eye tracking, and already there we had interesting results showing the difference between caseworkers and the people who were trained in using these formal models. There are many examples we are looking at right now, and in the financial sector, we for instance look at this white hvidvaskning, know your customer, so we can model the rules transparently. and thereby have it embedded in case management systems in the finance sector. And this also shows an example of a sub-process where there's some events that trigger that you should do this customer knowledge procedure, and then we can then describe this as a sub-process. We also have examples from GDPR. This is a decision tree used at Copenhagen University. No one, or maybe that's a bit rude, but not many people were actually looking at it. And if they did, it was not clear how to interpret it. And it was not recorded how people interpreted it. So it was just a piece of paper. So the tomorrow way of doing it is to actually formalize these decision rules. So we have a precise interpretation, and then we can actually provide this digital decision support tool based directly on the model. Then we can also record what are people actually doing. So we can come with the right help if people are stopping in the middle of a decision process. So the tomorrow picture of digital compliance is that we can have an interpretation of the law, preferably actually made by the people who make the laws, or the municipalities or umbrella organizations of municipalities or state government institutions. And then that can be used in several ways, either for the supervisory authorities, for the citizens who need to understand what are their rights, and for the businesses and public organizations. And then they can have the same interpretation of the law, but of course it should still be understandable. So a judge can come in and say, well, yeah, it's true, you had this interpretation, but I actually overrule and say, well, it's not the right interpretation. And that is possible if you can have this understandable model of the law, but it's not possible if the law is just a piece of code, or at least it's more difficult. So just for the people from the computer science background, where is DCR in the landscape of formal models? Well, on one hand, we have logic-based models, and a very classical example is linear time simple logic with past, where you can say statements like this, that if you see a notification in the future, you have to inform the notifier. If you have an acknowledgement, you must in the past or have had a notification. So this is very formal, and it's similar to what we have in DCR graphs, but these text-based logical expressions become very difficult to understand. And it doesn't have a direct operational interpretation, so you need to transform to some other, typically an automata-based model, to actually understand what is going on here. So you get a lot of gaps in interpretation and explanation. So we also have these automata-based models. There are many kinds of automata, finite automata, Bücher automata, timed automata, I/O automata, and we have these BPMN, business process diagrams, that are also a kind of automata, saying we have a starting state and then you can move on and execute the process. And the problem with them is that, well, it's pretty easy to see what you can do next if you are in a state. But to find out why you cannot do anything in a given state and how this relates to regulation is very difficult, because you don't have an explicit representation of the regulation anymore. You only have some of the parts. So it's like making a highway and throwing away the map, so you don't know where you can exit and how. So it's difficult to maintain when regulations change. So in between, we have these executable graph-based models. Could you elaborate on the example from the Ministry of Business, Industry and Finance? Yes, I can go back to that. I just want to say here that we have these executable graph-based models where we do not model all the states explicitly, like the automata, and we have a graph-based way of modeling the rules in a way so we can also directly execute it. And by building tools, and that's very important, so we're not just making the models, we have tool support for making the models. We can actually get non-programmers to make models and understand models and maintain models. And then we can execute them directly by changing a marking of the graph, just like we update a GPS map to see where are the cars, so we can see what have happened already and what is about to happen. So yeah, we actually elaborate a bit more now here in the financial sector, because we have some ongoing Copenhagen fintech projects. Then we can go back to this know your customer in the question if we have time. So these three projects is one where we look at how to map financial decisions, and so one could be the know your customer, but another one we're looking at right now is the definition of critical illness used in an insurance company. Right now it's much paper-based and in the head of the caseworkers. So by modeling the decision support here, then we can actually make it transparent to the management or the caseworkers, and also in principle for the citizens, so they can know what are the rules that actually apply when I use my insurance to get some compensation. And we can put that into the decision support interface, so we can get an online questionnaire based directly on the model. And yeah, so Hugo, you can take over and say a bit about the how we can then use NLP to extract data from text.
Definitely. So as Tijs mentioned, I mean, process mining, or at least process discovery, is the idea of using certain artifacts in order to generate a normative model and understanding of a process. And one thing is to use, for instance, dumps in a database, which we consider event logs, to generate a model. But the other way is how do we use other artifacts such as interviews, such as laws, such as process descriptions or SOPs in a company in order to build kind of the normative model. So what we do is we combine machine learning or in particular natural language processing to basically train models with the different utterances. I mean, we combine two different models. One is kind of a rule-based model in which we know what are how different tokens, different words in a model and different sentence structures correspond to a rule in DCR language. But another one is, well, the idea is that these models are trained with the time, and then we can learn different utterances, how different uses of the words mean with respect to a formal model. So what we do here is basically train these two models, combine them together, and then present this to domain specialists so they can actually see whether this is a correct selection or not, and then we can retrain based on in their opinions. And I mean, all this is goes in frame with the idea of compliance by design. And what we have in the digital tools for green legislation, DigiGreen, is how do we support the green finance legislation now. There's a new taxonomy regulation that appeared last year in 2021. And that provides incentives to different companies when they are building new buildings, and but that's only if they achieve certain degree of kind of greenness. Like you are building a new building, and there's certain regulations regarding materials, regarding processes. So one of the things that we right now see is that the institutions that are doing this, namely either the public state or financial institutions, need to do all this with consultants that are doing this assessment manually. So one of the things that we're building at the moment is these digital models of the regulation that supports the assessment, and also because the regulation is already in place and there are different cases, you can move to the different to the next model. Yeah. So the idea is that we can map this green taxonomy into a digital law. This is actually a model, one of the DCR models of paragraph 50 of the green taxonomy. And then on the other hand, we can take the historic cases to build up event logs. With that, we can actually use them together to apply a technique native from process mining called conformance checking, so we can see what is the deviation of the historic cases with respect to the legislation, and visualize whether this is actually this supports like an idea of compliance by design. Yeah. the next project we're working is, okay, now we are using we are using DCR, and it's actually a very flexible model. But one of the things is that well, how much flexibility, how can we support users in taking the right choices? So if, for instance, I want to become green, and I have already certain investments. How can I actually change certain investments in order to provide a better CO2 consumption? Right now, there is no way of doing that. So what we do is mapping the different activities, a different budget of activities in a household, into a DCR model. And all the alternatives, they are also combined with a multi-cost perspective. So you have, for instance, the CO2 consumption and the cost of investment. And we map this into a multi-perspective constraint optimization problem. So we can provide that with a time horizon and a budget horizon. And we can let the algorithm tells us in which way we can make certain changes, gradual changes into my consumption, so we can achieve a modeling goal.
Thanks a lot, Hugo. So I just want to say, now we are out of time, so I just briefly say that we have these projects going on in DIREC that we already mentioned. We have the projects with the Faculty of Law, one supported by Nordforsk, where we look at migration law, and then we have this foundational project also looking at how to build accountability and privacy by design into future program languages. So that was kind of the summary of this talk. Sorry that we don't have a lot of time for questions, and we had some technical problems in the beginning, but you are always welcome to reach out to me, Tijs, Hugo, all the DCR solutions, or go and have a look at our webpage for the research section for software, data, people, and society, and see what are we doing, because there's a lot of stuff, of course, going on in the section that we didn't cover in this talk. But the bottom line is that we are overwhelmed by legislations, regulations, and they are actually needed also for us to change our behavior, but we cannot keep up with this number of regulations. So it's a new approach to digital regulations and compliance management is really a highly overdue. And during the last decade of research and development, jointly with companies like DCR Solutions, but also KMD and NEC and other companies, we actually now have a groundbreaking technology where we can have an understandable mapping, not a perfect automation of law, and that's not the goal either, but a mapping that can be maintained by domain experts and non-programmers, so we can have a more transparent map of decision support and than we have right now, either in our head or in code that no one can understand. So, and as Hugo also showed, we are now doing these pilot projects in Copenhagen FinTech and AI Denmark to see how can we actually support sustainable decisions in business processes for citizens and businesses and public organizations. So yeah, that was all we had prepared for the talk today. I think I will turn off the recording, and then people can comment. Yeah, Tijs comment that this is actually his old email where he was a former place. So it's called Slaats without the T. And then this is correct. Yeah, sorry about that, Tijs. That's not my imperfect model inside my head. Yeah, so thank you for listening. People are logging out now, but please contact us if you have more questions, and I will stop the recording, and then you can also ask questions if you have time.